I'm Rosani from HoliMaker, and I'm speaking with Alberta from BioHalo. Tell us a little bit about yourself and a bit about BioHalo.
BioHalo is a Danish startup that was a spin out of the Danish Technical University here in Copenhagen, where I'm now. We are focusing on the production of bio-based polymers, which means materials that can be produced by organisms using renewable feedstocks.
What is bioplastic in general?
Bioplastic is a carbon-based polymer, very similar to the plastic that everybody think about. A real difference stands in how it's manufactured, where is the substrate, or like where is the plastic coming from, and if it's a type of polymer that can be degraded by in the environment. These are I think, the three pillars for bioplastics. It's actually a very broad term. What we do in BioHalo is a very specific niche application and type of bioplastics. In BioHalo specifically, we are using a bacteria that produces these polymers, and they can be used as plastics. Focus specific of BioHalo is to produce a very specific type of polymer which incorporates halogens using renewable feedstocks. And we are aiming to produce biological replacement to a group of products called PFAS, perfluoroalkyl alkyl substances, which are quite pervasive in our society, and they're used in a variety of applications and have great performances. So they are usually high performance material, but because of these high performances, they are also very persistent. They don't degrade, they accumulate in the environment and in our own body. And this is creating a lot of issues in both of health, but also environmental sustainability. And so our goal is to generate new type of polymers that retain some of these high performance characteristics, but are much easier to recycle or get rid of at the end of the use.
The research has been going on for about 2 decades at least. Why the need for bioplastics to kind of be more and more now, and how is BioHalo sort of helping to move in a new direction or a different direction?
Well, first of all, the biggest change was awareness in the society. So in the last years, we all know that environmentalism became a very big topic, and preservation of the environments and our planet. And also the understanding of people that we have finite resources in the planet. So extracting resources is not going to be enough in the long term. We need to find ways to produce what we need in a sustainable manner, meaning that the resources that we're using are going back into the productions, into a cycle. So the problem of normal plastics is that they tend to accumulate. We cannot really recycle them very efficiently. They end up in dump yards, in the oceans. There are plenty of examples, and I'm pretty sure everybody heard about them already. And not only this type of plastics that accumulates in the environment are harmful for the environment, but they're also lost. It's all material that is lost and we cannot use again. And so in the specific for BioHalo, these fluorinated polymers that we are trying to substitute, they are impossible to get rid of. They're impossible to recycle. The only way to get rid of them is to burn them at very high temperature, which first, it consumes a lot of energy, and second, it produces very polluting substances. So they're great, but they're not a real long-term solution.
The problem that BioHalo identified is the bioplastics is good, but because it's still not sustainable.
We need to differentiate two types of sustainability: the environmental sustainability, where I think bioplastics are scoring very well. There are very good and interesting studies that study the whole life cycle of a material, so from production to disposal, and they look at it in a global scale. So it's not enough that, for example, here in Denmark or in Europe, we do plastic differentiation and collection. If we then send it in a third world that has been in a third country and it's been used as a, it's been dumped there. On a global scale, it doesn't really make things better. Going back to your question, how we deal with this is that we need to find new solutions and new technologies, and also a lot of awareness. And because most of these bioplastics are available, they can be produced, but they're not economically sustainable, which is the second type of sustainability, right? Because the chemical industry has been producing these materials for a century now, And the chemical industry is one of the most efficient industry that humans performs. The efficiencies are crazy high because it's very expensive. They want to produce everything they can from the minimal resources possible. Bio-based production of bioplastics is not at that level yet. So it's very difficult when you're trying to produce, let's say, a plastic bottle, to produce it with a bioplastic and still be cost competitive. And I know that sustainability is a topic that is dear to many of us, but the reality is that when you're entering a market, you need to be cost competitive. Otherwise, people will not buy it. And so this is the other level of sustainability that we need to take into account is the cost. What BioHalo is placing is that we are trying to substitute a very specific type of polymers that are used in high-end applications, in which the material of the plastic is the cost is actually minimal compared to the rest of the final product, and the PFAS itself can be also quite expensive. So that's our entry market, the place we want to start, where we can actually, with the, I'm going to call it limited bio-based production capacity, we can still be competitive, develop our technology further, and give us the head time and to develop, to be cost competitive in all across of the industrial. Say we want to generate products for high performances, stuff that sometimes goes in heavy duty machines or in microchips and so on. And when we expose the fact that our material has some of the PFAS properties, but it's also biodegradable, people suddenly like, but our, I don't know, windmill for energy production need to last at least 20 years. If your material is biodegradable, how can I ensure that it lasts for so long? And it's a fair concern, but what we always reply is that it really depends on where the plastic is used, because biodegradable doesn't mean that it degrades out of thin air. It needs to be in the soil, it needs to be in the water, it needs to be an environment where there's a very high biological activities. A microchip that sits inside a computer will not, be exposed to this environment until it goes into a dump yard. And that's when the biodegradability becomes very important.
If you could, like, what are some of the projects that you have come up with or that you have worked with that kind of that shows these examples?
In our specific cases, we are focusing on coatings, to be more specific, so thin layers to functionalize surfaces. And we have been running tests on biodegradability and recyclability of our polymers. So the first one is it's technically called industrial compostability. So these are tests to see if a material can be degraded, not in the environment itself, but in a specific facilities that do composting in a temperature that's a bit higher than normal, and in specific soil that have a specific community of organisms that fastly degrade this type of plastics, which is where we envision our product to be eventually. Because what you want to do is, you don't want it to, going back to the cyclic uses of resources, you don't want it just to be dispersed in the environment. Ideally, you want it to be used for something else. And so if you can take your product, put it back into an composting facilities, and this composting is producing biomass out of your waste product, and then biomass can use, for example, to produce biofuels, or even to be used as feedstock for producing new plastics. You're conserving the matter, and your only input becomes energy at that point. So how and from where is this plastic produced? Of course, at the moment, most of the plastics are produced using fossil fuels and hydrocarbons, which are a finite resource, and it's also a resource that it was deep buried into the ground, and it should ideally stay there in order to not mess the environmental balance of our ecosystem. And that's where also bioplastic becomes very, very interesting, because you don't use this type of feedstock to produce your plastics. You're opening up actually to a different variety of feedstock. You can use the waste from agricultural land. You can use side stream for different type of food processing. You can use, there are some beautiful companies that are working on fermentation based on CO2. So CO2 becomes actually the feedstock, and there are bacteria that assimilate CO2, and they produce either biomass or precursor of plastics and other components. And then ideally you reverse the cycle. You are taking the CO2 from the atmosphere and you put it back into a plastic that can resist for a bit longer and can be disposed and put back into the ground and not go back to the atmosphere. So I think that's very, very interesting. And there are several solutions. I think the tricky part in all this story is what I mentioned before, LCA. So this very complicated, very thorough analysis, because it becomes very easy to think that a process is sustainable. But if you don't do your math and you don't do your proper calculations, you might find out that you're just moving that pollution somewhere else or somewhere else in the production chain. So it's very important to be thorough with this analysis. And what we see also is that people that are into the topic, also stakeholders, investors, and also end users are becoming very aware of the fact that it's not enough to say that your product is green. You need to prove it and need to have sound analysis behind it.
In general, it's a real problem. It's a real problem in the sense that you have the demand from the market who wants sustainable products, but to supply that demand is another conversation. We do it at HoliMaker. So we make machines that help to make prototypes and also material testing. So that's the HoliPress. And the HoliPress is being used quite a lot in research labs, in schools, and even in organizations, either for really material testing, like what you said, these new materials that are being created. We tried with PLA. That's the material that we've tested quite a bit on. But there are also other materials that are coming up almost on a weekly basis. And we don't have access to that because it's not part of our core business. But we know that there are companies who, like BioHalo, is looking at testing these materials. So if you're a company that's looking at that, you can give us a call at HoliMaker and we can have a conversation about that. To kind of wrap up our conversation in a few words, where do you see the future of bioplastic?
Well, I think so. First of all, the investments are necessary to drive the innovation. That is where I see their great potential. They need to, or they are changing their focus towards new applications, and they're pushing for a green transition because they know that their money is fueling innovation. So they kind of direct where the innovation goes, because we could very well just say like, oh, let's just make more plastics, and better plastics and not care about environmentability. In terms of the future of bioplastic, I think they're here to stay, and it's a necessity. And most importantly, because the fossil fuels will eventually run out, so we'll need alternative sources. But also, I really think that with PLA is a great example. It's been every year used in many more applications, and it's becoming more and more of a normal plastic that you find already at the supermarket, and you don't even know that. So a lot of the time these things become, I would say, silent transitions. The end user, the daily consumers that go to the supermarket, yeah, they maybe notice that plastic is a bit different. They might recognize that that's PLA, but they will just go ahead with their life as business as usual. The great difference is going to be made in the manufacturing part, and so I think we are driving a great battle here. Not sure how much we'll get recognition for it, but for sure it is the way to go. It is the future.
Well, thank you so much, Alberto, for sharing your expertise on bioplastics and what BioHalo does. If you want to know more a bit about BioHalo, you can contact Alberta. If you want to know more about HoliMaker and what we do, material testing, making prototypes with new materials, you can contact us at HoliMaker. Well, till next time, everybody, thank you so much.
Thank you very much. Have a great time.